Hello students, right now I am going to explain objective questions. Topic is aldehydes and ketones. Aldehydes and ketones. Once check in your objective material, page number 135, lecturer sheet, exercise 1. The first question is, which one of the following is not monovalent? Not monovalent. The given options are aldehyde. What is the formula of aldehyde? C double bond OH. B. Second one is the ketone. Ketone is represented like this, C double bond O. Third one, carboxylic. It is represented C double bond OH. D. Hydroxy OH. Once check the options properly. What he is asking, not a monovalent. Aldehyde, one side already hydrogen is there, second one is empty. So that is the monovalent. But in case of the ketone, both left side, right side, both are empty. So it is not in a monovalent. It is a divalent. Then go to question number 2. IUPAC name of the IUPAC name of hydroxy butyraldehyde. Hydroxy butyraldehyde. The hydroxy butyraldehyde is CH3, CH2, CHOH, CHO. This is the hydroxy butyraldehyde. Give the numbering functional group having the 1, 2, 3, 4. The second compound having the OH group is present. So 2-hydroxy. 4 carbons are present in the straight chain. That's why it is a but. And in between them single bonds are present. So it is represented by the air. And the functional group is the aldehyde. The name is ended with Al. 2-hydroxy butanol. Check the third one. When ethyl alcohol is passed over red hot copper 300 degrees, ethyl alcohol C2H5OH passed through the red hot copper at 300 degrees centigrade, which one is formed? The concept is the dehydrogenation, the catalytic dehydrogenation. Ethyl alcohol CH3CH2OH, it is passed through copper metal at 300 degrees centigrade. Dehydrogenation means removal of the H2. One hydrogen from the oxygen, second hydrogen from the oxygen attached carbon. In between the oxygen and hydrogen, oxygen and carbon, double bond will be formed to get CH3CHO. This is acetaldehyde. Fourth one. Compound formed when a mixture of vapors, formic acid and acetic acid is passed through MnO at 300 degrees centigrade. The given one is vapors of formic acid. Formic acid is HCOOH. And acetic acid CH3COOH passed through MnO catalyst at 300 degrees centigrade. Which one is formed? CH3 C double bond OH acetic acid, with formic acid COOH in presence of MnO catalyst. Once observe carefully, this CH3 and H both are gone in the form of CH3 C double bond OH, and this one underline one is gone in the form of CO2. Here one more oxygen is there, OH, and this hydrogen and OH group are gone in the form of H2O. CH3 C double bond OH plus CO2 plus H2O. Acetaldehyde will be formed. Acetaldehyde will be formed. Next, fifth one. Rosenmund reduction is used the preparation of. What is Rosenmund reduction? Acid chloride. This is acid chloride. It is reduced with palladium by barium sulfate in quinoline. This combination is called Lindlar's catalyst. One of hydrogen with Cl gone in the form of HCl. The RCO group with one H, we get aldehyde C double bond OH plus HCl. Aldehydes are formed. This is the Rosenmund reduction. Reduction. Only aldehydes are prepared, not for ketones. So answer is aldehyde. Check sixth one. Sixth one is also same one. Rosenmund's reduction only. What he is asking? Acetyl chloride. This is the acetyl chloride CH3COCl. Converts to acetaldehyde. CH3 C double bond OH. Which reagent is required? Once check the fifth one. The fifth one and sixth one both are the same pattern. In the fifth one we are taking the R. In sixth one instead of R he writes CH3. So the same reagent is required. This is the Rosenmund reduction. The required reagent is palladium by barium sulfate with quinoline. That is called Lindlar's catalyst. PD BaSO4 by quinoline. Reduction is required, that's why H2 is also required. H2 or 2H, no problem. Next, seventh one. On the dry distillation of calcium acetate, a compound X is formed. What is the functional isomer? Calcium acetate, CaO, C double bond O, CH3, O, C double bond O, CH3. This is the calcium acetate. This is upon distillation, we get X. They are asked functional isomer of X. Take the calcium acetate, CaO, C double bond O, CH3, C double bond O, CH3. This is the calcium acetate. This is upon distillation. Once observe this box. CH3 C double bond O CH3 comes out, and the remaining one is CaCO3. This is the X. He is asking what is the functional group of X is. The first option is acetone. The first option is acetone. The given compound, the formed compound is also acetone, so it is not functional isomer. Second one, acetaldehyde, CH3CHO. This is also not functional isomer. Why? Because the isomers must and should having the same molecular formula. We get X. The X is the acetone. It having 3 carbons. It having 2 carbons. So second one is also not possible. And option D. Option D is the butanone. No need to check it. We get 3 carbons compound. Butanone is the 4 carbons compound. So both are not functional isomers. Then option C is propanaldehyde. This is the propanaldehyde. The aldehydes and ketones are functional group isomers and both having same molecular formula. Then option C is correct. Next, 8th one. Dialkyl cadmium reacts with compound to form ketone. The compound is acid chloride. Take one more acid chloride. Reacts with dialkyl cadmium, gives rise to this RCO with R. RCO or this RCO with R. RCO or, and the remaining is the 2 moles of RC double bond OR plus CdCl2 will be formed. What is this? This is ketone. Next, 9. CH3CHO is obtained by the dehydrogenation of CH3CHO. Aldehydes. Aldehydes are formed by dehydrogenation of primary alcohols. Once check the option. Which option having the primary alcohol? First option, CH3CH2OH ethyl alcohol. It is passed through copper at 300 degrees centigrade. The 9th one is exactly similar to 3rd one. Here one hydrogen, here one hydrogen gone. We get CH3C double bond OH. Acetaldehyde will be formed. Next, 10th one. Acetylene on reaction with hypochlorous acid. CH triple bond CH reacts with hypochlorous acid, which will be formed. Acetylene, hypochlorous acid. Break one bond. Cl is attached to the one carbon, OH is attached to the one carbon. CH, Cl, double bond CH, OH. Add one more HOCl. Same pattern follow. Break the double bond. Cl is attached to the first one. OH is attached to the second one. CH single bond CH. Cl, Cl, OH and OH. Once observe the second carbon, it having the 2 OH groups. Carbon holds only one OH group. More than one OH group, it is unstable. To get stabilization, it loses water molecule to get CHCl2 and C double bond OH will be formed. That is dichloroacetaldehyde. Dichloroacetaldehyde. Next, 11th one. Which one of the following reaction cannot give CH3 taken twice, CH, CH2, COCH3? Which option does not give the given compound? Check the option A. What is option A? CH3 taken twice, CH, CH2C, triple bond CH. Once check which reagent is present on the arrow mark. H2O along with HgSO4 and H2SO4. If this reagent is appeared, first we add the water molecule to the alkyne according to Markovnikov rule and followed by ketoenol tautomerism. CH3 taken twice CH, CH2, C, OH, double bond CH2. We are adding water molecule. It is participated in the rearrangement. The double bond shifted to here, the hydrogen is shifted to here. We get CH3 taken twice CH, single bond CH2, C double bond O CH3. The same compound will be repeated. So A is not option. Then go to option B. What is option B? He give one cyanide, CH3 taken twice, CH, CH2, C triple bond N reacts with methyl magnesium iodide, CH3MgI gives rise to methyl magnesium iodide is splitted, CH3 get minus, Mg get plus. Why CH3 get minus? Magnesium is the second group element. First A and second A group elements have highly electropositive. So magnesium gets positive charge, CH3 get negative charge. C triple bond N upon broken, nitrogen is more electronegative. So nitrogen gets negative charge, carbon gets positive charge. So we get CH3 taken twice, CH, CH2, C, CH3, double bond N, MgI. This upon hydrolysis, HOH, break the double bond, hydrogen is attached to the nitrogen, OH is attached to the carbon, double bond is there. So we are taking the two water molecules, carbon having the two OH groups. If carbon holds two OH groups, it is unstable. C, OH, OH, CH3. For get stabilization, water molecule will be lost. We get CH3 taken by CH, CH2, C double bond O, CH3. Same compound will be formed. So B is also not answer. Once check the C. The given option is CH3 taken twice, CH, CH2, CH2, C triple bond N plus CH3MgI. This is the answer. How can you say? Once check the option B and C. Both are cyanides. Both are reacts with CH3MgI. In the option B, the given number of carbons are including cyanide 1, 2, 3 and 4, 5. But in this given compound 1, 2, 3, 4, 5, 6. So one carbon group is extra. So the formed compound is also having the one carbon extra. The option B and option C have same methodology. Finally we get upon hydrolysis. We get CH3 taken twice CH, CH2, CH2, C double bond OH will be formed. This is the answer because it is not related to the given compound. It is not related to the given compound. Option D, CH3 taken twice CH, CH2, CHOH, CH3. Arrow mark having the KMnO4 and H plus. Oxidation, remove these two hydrogens. Removal of hydrogen is also considered as a oxidation. Then in between the carbon and oxygen double bond will be formed. This is also given compound. So option C is the answer. Option. Then go to Page number 139. Some numerical questions are there. First one, that is the 29th in page number 139. How many different aldehyde isomers, including stereo, for C5H10O? He is asking for the including stereo. Options are CH3, CH2, 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 CHO. This is the first one. Second, CH3, CH2, CH, CH3, CHO. In the second option, we have one chiral carbon is present. The dotted carbon is the chiral. The chiral carbon shows optical isomerism. So, here one D form and one L form are possible. Next, CH3, CH, CH3, CH2, CHO. Next, CH3, C, CH3, CH3, CHO. Answer is total 5 possibilities we have. First one, the second one is considered as a 2, one D form and an L form, and the third one, fourth one. Total we have the 5 possibilities. Next, question number 30. How many different ketone isomers, including C6H12O? He is asking right now ketones. C6H12O. First one, CH3, CH2, 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 C double bond O, CH3. This is the first one. Second one, CH3, CH2, CH2, C double bond O, CH2, CH3. This is the second one. Next one, third, CH3, CH, CH3, CH2, C double bond O, CH3. Fourth one, CH3, C, CH3, H, C double bond O, CH2, CH3. Fifth, CH3, CH2, CH, CH3, C double bond O, CH3. Once observe it. Here, this carbon is the chiral carbon. If the chiral carbon is present, automatically it having the 2 forms D and L. So the fifth one is considered as a 2 members. 5 and 6 is closed. So next, seventh. The seventh one is CH3, C double bond O, C, CH3, CH3, CH3. Total we have 7 possibilities. So answer is 7. Next, 31. How many different enols, including stereo, for 4-methyl 3-hexanone? That is the given compound. He is asking how many different enols, including stereo. CH3, CH2, CH, CH3, OH, double bond CH, CH3. This is the first one. Here double bond is there. So here we are discussed about the EZ forms and cis and trans. So it containing 4 stereoisomers are possible. 1 EZ forms are discussed, and this carbon is the chiral carbon. It having the 2 optical isomers. 1 chiral is there and 1 double bond is there. E, Z and 2 optical, total 4. The given one is the ketone. By using the ketone, I am directly write the enol form. Next, CH3, CH2, C, CH3, double bond, C, OH. CH2, CH3. This is the second form. It does not have any chiral. Only double bond is there. By using the double bond, we are writing the EZ. It having the 2 stereoisomers. Total 4 plus 2. Total 6 isomers are possible. (32) How many of the following reaction produce ketone? We want ketone. Option A, the given compound CH3C, CH3, double bond C, CH3, CH3. Arrow mark having the O3, ozonolysis. The O3 is there. Simply break the double bond. We are adding 1 oxygen on left side, 1 oxygen on right side. So we get 2 moles of acetone will be formed. This is ketone. So option A gives the ketone. Option B, or C double bond OH. It reacts with SOCl2. We get RCOCl, acid chloride will be formed. The formed acid chloride, take 2 moles, reacts with dimethyl cadmium. This RCO with CH3, this RCO with CH3. We get RC double bond OCH3, 2 moles will be formed along with cadmium chloride. Here also ketone will be generated. So option B also gives ketone. Option C, CH3, CH2, CH2, C, CN, H, CH3, RMGX, followed by hydrolysis. In the previous questions, we are discussed about this type of equation. Simply, if the cyanides reacts with Grignard reagent, followed by hydrolysis, simply the CNs like that, CH3, CH2, CH2, CH, CH3, here C double bond N, here we are adding the R, here we are adding the MgX. Hydrolysis, break this bond, carbon is attached to OH groups, nitrogen is attached to hydrogens, but the carbon attached to OH groups, it is highly unstable, so it turns into C double bond O, it having the R group. It is also ketone. Option D. What is option D? Benzene having the CH3, it having the CrO2Cl2, chromyl chloride, Ac2O, and followed by hydrolysis. What is that? This is the Itard reaction. Once check in your notes. In case of Itard reaction, we get benzaldehyde, CHO. So this is not answer. Only option A, option B, option C gives the ketones. So answer is the 3. Next, 33. What is the given compound initially? Acetylene is given. 3 moles of acetylene. Passed through iron. Arrow mark having the heating symbol is there. What is the reaction? In your first year, organic chemistry, benzene preparation, acetylene gas is passed through the red hot iron tube. We get benzene. That is the A. It reacts with CH3Cl and FeCl3. This is also well-known reaction in your first year. Present in 8 marks long answer. Friedel-Crafts alkylation. Benzene reacts with CH3Cl. We get benzene having the CH3. We get methyl benzene, that is B. The formed methyl benzene reacts with 2 chlorines in presence of HNO. Here once observe the reagent carefully. We are doing the reaction in presence of the sunlight. In presence of the sunlight, side chain substitution takes place. For suppose, in the same reaction, instead of HNO, Lewis acid like AlCl3 is present, electrophilic substitution reaction takes place and Cl is attached to the benzene ring. But here HNO is present, so we get benzene CH Cl Cl. This is the side chain substitution reaction and followed by hydrolysis. What happened? HCl gone. The Cls are replaced by the OH group, CH, OH, OH. But carbon holds only one OH group, so it loses water molecule and to get benzaldehyde. That is X. Well, what is asking? How many number of carbon atoms are present in the X? Number of carbon atoms having the benzene ring is there. The benzene ring having the 6 carbons and it having the one aldehyde group is there. It having 1 carbon. Total 7 carbons are present. Next, 34. 2x gives rise to calcium hydroxide. B upon heating, pH C double bond O pH. Number of sp2 carbon atoms are present. Once observe it, calcium hydroxide is the base. Generally, base reacts with acid to form salt. But the formed compound having the benzene rings are present. So, the X is C6H5 C double bond OH benzoic acid. Write one more benzoic acid. It reacts with calcium hydroxide. From here HOH, from here HOH will be formed. We get C6H5 C double bond O Ca O C double bond O C6H5. This is B. This upon heating, calcium salts upon distillation, we get this is the product, and along the product CaCO3 C6H5 C double bond O C6H5 plus CaCO3. What he is asking, in the formed compound having how many number of sp2 carbons? What is the compound? This is the benzene and having C double bond O and benzene. In benzene, all carbons, all carbons have sp2 and this is also sp2 because in benzene each carbon is attached to the double bond. Each carbon is attached to double bond, that's why sp2. So, in the first ring, 6 carbons. And second one having the 6 carbons total. But once asking, he is not asking in the final product. He is asking in the X. What is X? The X is benzoic acid. X is benzoic acid. This is the X. He is asking how many number of sp2. In benzene ring, all carbons sp2, and this carbon having the double bond with sp2. So 6 from benzene, 1 from CO, total 7 carbons having sp2 hybridization. Next, 35. What he is asking? Number of compounds theoretically possible for the formula C3H6O, excluding stereo. 9 possibilities are there. Once check in your IPA notes. In the first page, isomerism topic is there. At the isomerism, functional group isomerism heading, and the functional group isomerism I explained for the C3H6O. Once check it. How many number of functional isomers are formed? Total 9 functional isomers are possible.